and we'll begin in just a moment. Okay, it looks like we still have a few participants joining, but I can go ahead and get us started. So hello and welcome to the second installment of the Building Envelope Campaign webinar series. In this series, we're sharing technical assistance and recognition opportunities through 4 of DOE's technology campaigns. The Building Envelope Campaign, the Efficient and Healthy Schools Campaign, which spoke at our last webinar, the Integrated Lighting Campaign, the Storm Window and Insulating Panel Campaign. It highlights free engagement and recognition opportunities and features campaign staff and participants sharing practical approaches to improving energy efficiency. Before we dive in, there are a few housekeeping points I would like to cover. Please note that today's webinar will be recorded and archived on the Better Building Solutions Center. We will follow up when today's recording and slides are made available. Next, attendees are in listen-only mode, meaning your microphones are muted. If you experience any audio or visual issues throughout the webinar, please send a message in the Q&A box located on the bottom of your Zoom panel. My name is Haley McLeod, and I will be your moderator and first presenter today. I am at Oak Ridge National Lab, and I'm the lead for the Building Envelope Campaign. I've been at ORNL for a little over 2 years now, and I joined ORNL after about 5 years in industry as a lead reviewer and sustainability consultant. My colleague, Dr. Pil J.M. from ORNL will also be speaking on his expertise in multifamily buildings. Next slide. So like I said, you're going to hear from several campaigns today. So I'm taking us through our welcome and introduction right now. Then I will talk about the Building Envelope Campaign, and Dr. Pil J.M. will talk about his expertise in multifamily buildings. Then we're going to switch presenters and hear about the Integrated Lighting Campaign and the Storm Window and Insulating Panel Campaign. And then we will switch presenters one last time and hear about low-E storm windows and where those fit in multifamily buildings. And then once we've wrapped all that up, we should have time for a short session of audience Q&A. Next slide. Okay, so I'm going to get started on the Building Envelope Campaign. So I always like to start my webinars by saying thank you to our organizers, the American Institute of Architects, or AIA, the International Facility Management Association, or IFMA, and the International Institute of Building Enclosure Consultants, or IBEC. These folks have been with us since before the campaign even launched and give us really invaluable feedback. So I always like to say thank you to those folks. Next slide. So the Building Envelope Campaign really came out of a goal to figure out how to assess the overall building envelope performance without accounting for how the building is being used. So really drill down on just the envelope performance. Next slide. So lots of engineers who are not me worked to develop this metric, but basically the HVAC cooling and heating demand is dependent on the building envelope energy load and the internal loads of a building. And so again, we were really trying to highlight that piece that's in green there, that building envelope energy load. And so the main thing I wanted to point out here is that the building envelope performance metric that we're using for our campaign does have the same unit as EUI, but instead of being spread across the square footage of the building, it's spread across the envelope area of the building. Next slide. So what is the Building Envelope Campaign? So there are several current ongoing campaigns, which is the point of getting everybody together so we can kind of present to you guys in one fell swoop. So this is one of the current campaigns, and it was really just designed to help create more energy efficient buildings in the building stock in the US. And we're doing this by introducing a new building envelope assessment metric and a tool for helping you determine that metric. And we are calling that tool metric the building envelope performance value, or BEP value. Next slide. So what are the goals of this campaign? You launch it, you have to have intention. And so we were really hoping to motivate action and increase awareness of the value of investing in these high performance building envelope technologies. And that is for both new and existing commercial buildings, which means that we're interested in new buildings and we're interested in retrofitting existing buildings. We wanted to recognize leaders who were achieving really high performance in their buildings through these high performing building envelope measures. And then we wanted to demonstrate and document energy and cost savings, sorry about my dog, with integrated design, construction, commissioning, and maintenance from implementation of these high performing envelope systems. So motivate action, recognize those folks that are out there doing the work, and then work with those folks to demonstrate and document those savings. So we do have I'll talk about them a little bit later, but we do have details from all of our successful year one participants up on our website where you can go learn more about those energy and cost savings. Next slide. So how are we going about achieving these goals? And the short answer is that we couldn't do it alone. We have to do it with a network. And so that's where all of you come in. So we have supporters and participants who engage with us in our campaign. Our supporters have full access to our technical expertise regarding envelope technologies. They partner with the tech team to help spread the word about the campaign, and they are recognized on our envelope campaign website as supporters if they choose to be. As for our participants, those folks also have access to the campaign resources and technical expertise. They're able to work with us to stay informed on envelope technologies and resources. But then the main thing that our participants do is use our assessment tool, enter their building information into the assessment tool, and then hopefully achieve awards for their buildings. Also, after that point, we can then work with them to develop case studies and short videos, additional information about their buildings that we can use, to help spread the word about these technologies. Projects completed since January 2019 are eligible to submit. Like I said, it's new construction and retrofit buildings, and it's all commercial buildings in addition to multifamily buildings. Next slide. So like I said, our participants go to the website and enter their information into our assessment tool. And so the assessment tool will give you your percentage improvement between, if it's a retrofit building, between your existing building and the retrofit building. And if you're a new construction building, between the relevant code for your building and your as constructed building. So our retrofit tiers of recognition are either a 30 or 50% improvement in that envelope performance. And then for new construction, it's either a 20 or 40% improvement in that building envelope performance. So the reason those retrofit tiers are a little bit higher is that we assume that there's kind of more improvements to be made between an old building that's being retrofit as opposed to just comparing over code. So that's why those numbers are a little bit different. Then on top of either of those two tiers, we also have role model awards. So if you've achieved your Retro 30 or 50 or your Novel 20 or 40, you are also eligible for either a technology role model award, or new this year, we have an equity and energy role model award. And so for a technology role model, this may be that you've incorporated something really interesting in your building that's a cutting edge technology, really serving as a proving ground, and we would like to share that information with the public. Alternately, the equity and energy role model award, which like I said is new this year, we are still sort of developing what that means in detail, but it could be the end use of the building, the community that the building is in, where those cost savings are actually being recognized in a community. So we're kind of excited to see what happens with that equity and energy award this year. And then final thing, we do have honorable mentions. So if you come in right below that Retro 30 or Novel 20, but still are still assisting the campaign in a real way. Maybe you've submitted a whole portfolio of buildings and you just had this one that came in slightly under, or it's a retrofit building that was just already in really good shape. So you still have a highly performing building. It just didn't quite hit that 30% improvement. You may still be eligible for an honorable mention. So we do encourage folks to submit even if you are right at that cusp. Next slide. So quick cover of our timeline. We are wrapping up our second year. We launched at the 2020 Better Buildings Summit. We are always open for new participants and supporters to sign up. And we are always accepting and reviewing submittals from participants. Like I said, all projects completed since January 2019 are eligible to submit, and our spring submittal deadline for recognition this summer is Friday, April 8th, 2022. And then I always like to remind people that this campaign is free and obligation free to join, and that it's really easy to switch from a supporter to a participant. You just have to email me. So if you aren't sure, I do encourage you to go ahead and sign up. Next slide. Wanted to summarize our year one very quickly. We had 14 buildings that we were able to recognize that covered 1.5 million square feet of conditioned floor area and an annual savings of 9 million kBTU based on those envelope technologies alone. And we did get all types of buildings that submitted in year one, including multifamily buildings. Next slide. Just a quick slide here. We have 4 retrofit projects that we awarded last year. Next slide. And then the rest were new construction projects, including the Virginus Community Housing Project, which was a multifamily project. Next slide. So that is my summary on the Building Envelope campaign. And now I am happy to pass it over to someone with more technical knowledge than I have, Dr. Pilje, and one of my colleagues at Oak Ridge National Lab. Thank you, and take it away, Pilje.
Thanks, Haley. Hello, everyone. My name is Pilje, and I'm a R&D staff and sub-program manager for the Building Energy Modeling at Oak Ridge National Laboratory. I joined the lab about 13 years ago, and I have been involved in many building energy modeling projects and technology field evaluation and analysis. And currently, I am also serving as lab point of contact for the low carbon project for the multifamily sector. So in this webinar, I will start with some basic introduction of the multifamily building energy characteristics and what are the current barriers in energy retrofit of multifamily buildings. Then a use case for energy retrofit of a multifamily building will be presented in this webinar. And this use case will give you some general idea how a typical energy retrofit is done in the multifamily building and what can be done differently if we have some different approach. Next. So here are some quick facts regarding the multifamily building. First, almost over 30% of the US population lives in the multifamily building, and multifamily buildings uses about 15% of the residential delivered energy consumption. And high percentage of low-income household lives in multifamily building apparently, and they use almost 20% of their monthly income on energy bills. So their burden for the energy bills is much higher than the level of the people, other stage of the people. And in addition, most existing multifamily buildings were built before 1990s and sometimes more than before 1970s. And which means they are mostly energy inefficient. So we can see that there are lots of the potential to save energy, and this can reduce the household burden for the energy bills. And one study performed by the ACEEE shows that the current programs have shown that the comprehensive retrofit can cost effectively improve the energy efficiency of the multifamily buildings by 30% for natural gas and 15% for electricity. Nationwide, this level of savings would translate into the annual utility bill cost savings of almost $3.4 billion for the multifamily sector. Next. So although there are significant opportunities for energy savings in multifamily buildings by retrofitting existing multifamily buildings, there are several barriers existing today. As almost 90% of multifamily buildings are rented and 70% of tenants are paid for their utilities, there is no strong desire from the owner of the building to retrofit their properties. And although there are some incentives and programs and incentives for the building owners, it's not well informed to the owners, and they are not really doing the retrofitting. In addition, uncertainty of the energy savings can hamper the building owner to participate in the retrofit program. Finally, there is a lack of systematic analysis. And in other words, most of the retrofit has been done based on a one-size-fits-all approach originating from the accustomed practice, best practice, and intended merely to meet the code compliance requirement. So this hampers the opportunity to do better in retrofit of the existing multifamily buildings. So from next slide, I will present a case study to show how a typical multifamily retrofit will be performed and what are the typical energy savings and how we can do better. So the case study shown in here is about the multifamily building retrofit project in Union City in Georgia. The building was originally built in 1993 and there are about 11 buildings with the 3 different plans. The building owner expected and targeted 20 to 30% energy savings, and funding was leveraged by combined affordable housing subsidies and private equity. Next. There are several the implemented measures and pretty typical measures as you can see here, and I will go through the individual measures to explain why they selected these things. Next. So this table shows the comprehensive list of the measures pre and post. Basically, existing column in the middle, it shows that the pre-condition of the building and improvement is the basically what they've done for the building. Next. So first one is the foundation. And we found the existing foundation condition was pretty bad, and with the deteriorated the insulation and vapor barrier, and this was repaired and reinforced with the more insulation, as you can see from the right side of the picture. Next. There was no specific energy upgrade for the exterior wall. They only replaced the siding and front fascia. And next. And ceiling insulation, it was the R30, and then they added more insulation to have the R38. Next. For the windows, they have a pretty inefficient single pane aluminum frame, the glazing unit, and they replace it with the double pane low vinyl frame. Next. And of course, that the existing low efficiency, the HVAC system was replaced with the high efficiency one. Next. And electric water heater was also replaced. And it was pretty old unit, but the new unit has a little bit higher the energy factor, which is a higher energy efficiency than the existing one. Next. And all the lamps and the incandescent and the fluorescent light has been replaced with the compact fluorescent light fixture. Next. And major appliances were also replaced with the Energy Star qualified ones. And next. And finally, we have done the guarded blow door test for this building to find out the infiltration rate of the building, air tightness of the building. And also we shield the gaps to reduce the air leakage roughly 25%. And this reduced the air infiltration was verified before and after blow door test. Next. So when we were engaged in this retrofit project with the partner, the measures were already selected, and the selection process of the measures were basically based on the best practice without no in-depth analysis. So in this stage, we attempt to see how the retrofit selection can be done differently based on in-depth whole building energy analysis. Next. So here is the process of the whole building analysis. First, we collect the pre-post building characteristics and build a baseline building energy model. Next. And we also gather the pre-retrofit monthly utility bills from the existing building and actual weather data, and also get some monthly energy use from the bills. Next. Then the baseline building energy model was calibrated with the monthly energy use. Next. Then this calibrated model was used to implement the existing ECMs, the initial ECMs energy conservation measures are applied to the calibrated model. Next. And at the same time, we also apply the optimized ECM, which is alternative ECMs we found from the other resources. Next. And then we show this energy savings analysis. Next. So for the interest of the time, I don't show that all the detailed analysis, but this is a kind of findings and summary of our analysis. So implemented the original retrofit package, capital cost we estimated about $39,000. And this calibrated simulation shows that there is some 24% of the potential energy savings. And when we calculated the simple payback, that was about the 10 year of the payback. And then we evaluated the other energy conservation measures not included in the original list. And we do some kind of the sensitivity analysis and then replace the payback, the measures with the the optimal energy conservation measures, and do some work. And we found that with a little bit of the increase of the cost, which is about the $41,000 the capital cost, we can realize 34% of the potential energy savings with the reduced payback, which is a 7 year of the payback. And there are other findings from this project. Basically, some certain retrofit for the improved building appearance. The certain retrofit is not for the energy retrofit. It's more about the improved building appearance and durability, like a wall siding and roofing replacement. But this can be integrated with the energy retrofit with just a little bit of the incremental cost, because they are anyway removing the existing structure or some sidings and replacing the siding. If they add some little more cost, they can add some value for the energy retrofit. And after they retrofit the building envelope, we can expect the building load can be reduced, and we can probably reduce the size of the HVAC system, which can reduce the initial cost. But there was no attempt to properly size the HVAC system. And we found that the existing building has some ventilation deficiency before the retrofit, but after the retrofit, it was not really addressed properly anyway. Next. So in summary, as you can see, there are high energy savings potential in existing multifamily buildings, but this potential usually remains unrealized due to the apparent difficulty in the diagnosing the multifamily buildings first, and evaluating alternative measures, and installing customized set of the measures. And we found that the systematic approach for the retrofit analysis can be followed to maximize energy savings in a very cost-effective manner. So this is the presentation next. So I'm gonna pass this presentation to the Allegra Steenson.
Hi, everybody. I'm Allegra Steenson. I work at the Pacific Northwest National Lab as a research scientist, and I work on the Storm Windows and Insulating Panel campaign, doing a lot of research as well as energy modeling. I'm also going to be talking about the integrated lighting campaign today, even though that is not one of the projects I am working on. Next slide. First, I'd like to take just a couple minutes to talk about the integrated lighting campaign, like I said. Next slide. Great. Just like the name sounds, the integrated lighting campaign focuses on recognizing integrated lighting projects, which means that the lighting system can communicate with other building systems to enhance building performance. Integrating the lighting system with other building systems can achieve deeper whole building energy savings. For example, by exchanging information with HVAC systems or controllable plug loads or supporting the Internet of Things. But that's not all this campaign is interested in. There are still luminaires and luminaire control systems that the team is hoping to capture as well. Advanced systems and controls in lighting that improve lighting performance are of interest, and the ILC would love to hear how systems are going above and beyond simple occupancy, daylighting, and scheduling approaches. Through the ILC, we hope to learn about and recognize some of these innovative lighting projects, as well as supporters of these projects. Submissions for recognition is now open and will close on March 30th. So if you're aware of a project that would be interested in getting recognized, you can visit the Integrated Lighting Campaign.energy.gov, or you can email the campaign organizers. Next slide. Axel Pearson at the Pacific Northwest National Laboratory would be happy to discuss, or you can send a general inquiry to integratedlighting@pnnl.gov. Next slide, please. Next, I would like to tell you about the Storm Window and Insulating Panel, or SWIP campaign. The SWIP campaign is a collaborative initiative sponsored by the Department of Energy and managed by the Pacific Northwest National Lab to accelerate the adoption of low-E storm windows and insulated panels, delivering energy savings and comfort in residential and commercial buildings at a fraction of the cost of full window replacements. Inefficient windows waste energy and cost millions of dollars every year in heating and cooling. And the goal of the SWIP campaign is to leave no poor performing window uncovered. Next slide, please. The SWIP campaign aims to increase awareness, visibility, and build the body of knowledge about low-E storm windows. When people think of storm windows, what comes to mind are old, unattractive storm windows that need to be removed and put up seasonally. But these modern units are not your grandma's storm windows. The campaign also acts as a national platform for collecting and sharing information and best practices related to storm windows. We work with utilities and energy efficiency programs to justify, launch, and promote new utility and energy efficiency programs. One aspect of this work includes modeling state-specific energy savings associated with low-E storm windows for submission to state technical reference documents, which utilities will then use to inform what programs they're going to implement. The SWIP campaign serves as a one-stop shop for resources and technical assistance to help overcome barriers to adoption. And we also work with weatherization agencies to provide support to increase the adoption of low-E storm windows into their programs. The campaign also provides national recognition for organizations that have demonstrated success in their adoption or promotion of this technology. Next slide. If you're interested in adopting or implementing low-E storm windows, the SWIP campaign is here to help. By joining the campaign, participants can stay up to date with the latest campaign news in the form of our campaign newsletter, learn about best practices for including low-E storm windows in your program, connect with low-E storm window manufacturers, receive technical assistance, and receive national recognition for demonstrating success in adopting or promoting low-E storm windows and insulating panels. Together, we can leave no poor performing window behind. If you want to learn more, you can visit the SWIP campaign webpage, contact us through our Tech Challenge email, or reach out directly to myself or my colleague and campaign lead, Christian Valoria. And with that, I will hand it off to Tom.
All right, thank you. This is Tom Culp. I've worked the last 25 years with the glazing industry, with both manufacturers and on multiple DOE research projects and consulting with PNNL, including some of the early on research projects around low-E storm windows and panels. So next slide, please. So I'll be talking about basically how low-E storm windows and panels, what are they in terms of a modern context, and how can they be used to cost effectively retrofit existing windows in existing buildings, today focusing on multifamily. Next slide, please. So first, looking at the opportunity, this shows for residential, so not just multifamily, but all homes. There's, DOE, and then KD Corp from PNNL did a market study, shows it's roughly 19 billion square feet of existing windows. And it might surprise you, but about 40% of that is single pane glass. And then a similar amount is double pane clear windows, meaning older windows without low-E, not modern, not what we would consider energy efficient in a modern context. So that's a huge amount of older windows, huge amount of wasted energy, and an opportunity for upgrades. Next slide, please. So we know that there's a lot of great new window technology, glazing technology, low E coatings, modern frames, gas fill, and all that. The Energy Star Windows program is a prime example. But that's not always the right solution for everyone. If we look at the numbers, only about 1 to 2% of the potential existing windows are replaced every year. So it's going to take a very, very long time before all these older windows are addressed. So what do you do when when rip out and replacement of an existing window is either impractical or cost prohibitive? You're looking at income sensitive populations as well as high rise or places like that. What if it's not allowed or you don't want to replace existing windows, in particular in historic buildings? What do you do? Next slide. So one solution are modern low E storm windows and panels. And I'll talk a little bit about this. And as Allegra said, these are not your grandmother's storm windows. This is something new and different, incorporating low E glass, which I'll talk about. And it can be viewed as both a insulation and an air sealing measure for upgrading your existing windows at a fraction of the cost. Some of the cost estimates show that because you're avoiding some of the heavy labor and disposal costs, that it can be 1/4 to 1/3 of the cost of full window replacement, yet you can achieve similar energy savings. These are modern products. They're aesthetically pleasing, coming in all sorts of colors. They can come in custom colors. And the photos you see here show that. So these don't look like those clunky old things from the 50s. They're made for permanent year-round installation. They do not have to be removed seasonally, which we often hear people, that's what they think of when they think of old storm windows. They can be operable or fixed, so they can open up for natural ventilation. They can be interior or exterior. The 3 photos on the left all show interior applications. The 2 photos on the right show exterior low E storm windows. And in addition to the energy savings, they improve comfort, thermal comfort, as well as acoustics are two of the main applications. And real quick, I'd like to acknowledge and thank the companies who provided all the photos throughout this presentation, Quanta Panel, Larson Manufacturing, and Alpin. Next slide, please. So this is just an example of a number of real life buildings. So we often think about low E storm windows for low income weatherization, and that is a very prime application for them, but it's not limited just to that type of application. It's useful anywhere in any type of buildings, from historic applications to the building on the lower left there, that's in the US Naval Academy. It's a 110-year-old building that they had to upgrade the windows with a custom seafoam green window, and to just regular homes, to even high-rise buildings. All these are real-life applications showing the use of low E storm windows, either exterior or interior. Next slide. So I mentioned low E glass or low E storm windows. So what is that? So you've probably heard about this in terms of new windows, Energy Star windows, and so forth. But low E stands for low emissivity, and it's a transparent microscopic coating. This is actually one of the first applications of nanoscale technology. Before that was a buzzword, but it's a transparent coating that you see through. It is a window after all, yet it reflects the radiant heat, the infrared heat, back into the home. So it reduces the building energy usage by cutting that radiative heat loss. Next slide, please. And the best way you can tell this is with IR imaging. So this is a 3 windows. There's 2 on the sides and 1 in the middle, all single pane glass. The ones on the left and right have been addressed with low E storm windows. The one in the middle was left alone. And this is an IR image taken from the exterior. And you can see the dramatic improvement. So you can see that temperature difference, that heat loss coming out of the original single pane window in the middle, whereas to the left and the right with the low E storm window, the heat loss is greatly reduced and it's looking similar to the exterior walls. So it's greatly improved performance. Next slide, please. So now the amount of the improvement depends on the existing window type. So if you're talking about single pane windows, the U factor again depends on the exact window profile, wood, vinyl, and what type of window. But we've done a bunch of modeling, which shows that basically U factor decreases about 50 to 60% with the low E panel. Over double pane clear glass windows, so older windows without low E, but you add a low E storm window, you turn that double pane window into a triple pane window, you're still decreasing the U factor by about 40 to 50% with that low E panel. It also improves the solar heat gain. And solar heat gain is reduced by about 20% with a standard low E storm window. And if you are in a mixed climate where you have both cold winters and hot summers, there are solar control low E glass options that will lower the solar heat gain even more. And then more recently, there's some new technology out there which incorporates adding a dual pane secondary window, some using thin glass, where you add 2 panes of low E glass to the existing single pane window. So you're bringing that single pane existing window up to a triple pane window in one step. Next slide, please. So we've done a number of case studies. This was one of the first ones between 2003, 2006, and on low-income weatherization homes in the Chicago area, where they doing nothing else in the home, just addressing the windows, added low E storm windows. They saw a reduction in the heating load of the home by 21%. Simple payback was 4.5 years, so very cost effective when these products are expected to last 20 years or more. And they, as I mentioned, it not only are you insulating the existing window by upgrading, you're also reducing the air infiltration. And so blower door tests that show that just by addressing the windows, not doing any other air sealing in the home, you reduce the overall home air leakage by 6 to 8%. So that showed how much air leakage was occurring through these older existing windows and what potential there is for dramatic reduction in air leakage of the whole home. Next slide, please. Moving forward in time, there was a DOE research project in 2010 to 2013 that I was involved with, where we wanted to repeat this work for 10 older homes in a mixed climate. So this was in the Atlanta area, places that have cold winters but hot summers, where all had single pane windows. We addressed them with low E storm windows, and we saw 15% heating savings, a wide range in cooling savings, anywhere from 2 to 30%. Some of that is because it's a highly wooded, these are older homes in the Southeast, so tree cover and issues like that create quite a bit of difference in terms of cooling demand. But overall, we saw very good energy savings. And again, we saw very significant air leakage reductions, 17% reduction just by adding the low E storm windows to the existing windows. Additionally, the occupants, some of from their perceived benefits were more than the energy. They saw improved, through surveys, they saw improved home appearance, reduced drafts, improved comfort, and reduced noise reduction. And to them, that was actually equally important as the energy bill reduction. Next slide, please. As part of the same project, we addressed a multifamily building in Philadelphia, actually 2 large multifamily buildings, one of them shown there, low but large. So overall, we addressed 101 apartments. In this case, they already had old style clear glass storm windows over single pane windows, but they were in pretty poor shape. So we replaced the existing storm windows with modern new low E storm windows. And just by doing that, we saw a 20% reduction in heating energy use and a 9 to 10% reduction in cooling energy use. And additionally, once again, when we did blower door tests on isolated apartment buildings or apartment units, we saw a 10% reduction in the air leakage of that apartment unit just by doing the windows, and that's it. So very significant. Next slide, please. And then lastly, PNNL, Pacific Northwest National Lab, has their lab homes up in Richland, Washington, which is climate zone 5. It's a pair of homes that are like twin homes designed to match each other, highly instrumented for detailed measurements, designed to represent older homes so that they can test a number of technologies, not just window stuff, but heat pumps, control systems, cellular shades, all sorts of features that you can use to address it, but in a side-by-side comparison, so you can very clearly measure the energy improvement from different technologies. So one of the projects was to add exterior low E storm windows and low E storm doors over the existing double pane clear glass aluminum windows and doors. And there we saw a 10% annual energy savings from this upgrade. And if you think about, we basically turned this double pane windows into a triple pane low E. And interestingly, they had done another study where they replaced some of these windows with triple pane low E windows and saw a similar improvement. So it showed that the concept was what we expected, that adding a modern and get a similar energy savings as a full window replacement, but at a fraction of the cost. And the payback period in this case was about 5 to 7 years. Next slide. So on the web, a number of states you need their assistance. So the big study back in 22 cities across all 8 climate zones. This analysis we did for 39 different single-family, semi-detached, and row homes. It was found to be very cost effective. In this case, you're looking at SIR, or savings to investment ratio, and you have to have greater than 1 to qualify as a weatherization measure in these programs, and the higher the number, the better. And in climate zones 3 through 8, when you install low E storm windows over single pane windows or over double pane metal frame windows, we saw SIRs ranging from 1.2 up to 3.2. Depending on the specific location, obviously more energy savings the colder you are, but also it depends on your fuel prices. So place, especially if you're using something like propane versus just natural gas in more rural locations, those SIR numbers are even higher. So it's very cost effective. And we should point out that, as the market study shows, that over 30% of windows are still single pane in climate zones 3 through 8. Next slide, please. And then again, this is just some more photos showing specifically multifamily. I should point out that NEAT study we did, that weatherization assistance study we did, that was mostly for single family homes as well as some semi-detached and row homes, but we expect the results to be similar for multifamily. And this is just showing an example of the range of multifamily buildings that have been done in real life with low E storm windows. There are exterior windows in the far left pictures. You'll notice both those happen to be 3-story buildings, and where it's a little easier to access from the outside. If you have a taller building, then obviously you might want to consider interior low E storm windows so that you can address them very easily without having to have cranes or use window washing scaffolding or anything like that. So you can easily address them from the inside. Interior low E panels also tend to be more airtight, so that's especially beneficial and helpful if you have a large stack effect in some of these older buildings that are tall. Next picture, or next slide, please. Last thing, and I noticed while there's a question that came up about, well, there's a disconnect sometimes in multifamily between tenants, those renting the apartments versus the building owner. And there's a disconnect in terms of motivation that depends on the pay model, who's paying for the energy costs, the utilities. But sometimes there's a disconnect, and the question was, is there any motivation or anything out there that can encourage building owners, multifamily building owners, to upgrade their buildings? And so I wanted to, whoever asked that question, this is directly aimed at that. There's a new phenomenon out there known as building performance standards. And so on top of federal programs or building codes or programs addressing new buildings, specifically, there's building performance standards, which are really taking place at the local level. So these are more proactive cities and a few states that are trying to address climate change by addressing existing buildings. And they do it first by energy disclosure laws, which basically say buildings over a certain size or buildings of a certain type have to report their utility energy usage publicly in a public database every year. And so that's to help people to know what their energy use is. But then the next step are building performance standards, which take those numbers and then apply limits to it. So it can either be a building energy use limit or a carbon emission limit. And if you're above that limit, you're going to pay a fine or a penalty every year. And these have been enacted in all the places listed there. New York City was the first. We also have St. Louis, Boston, Washington State, District of Columbia, and Colorado. They each do it a little differently. Some use carbon limits, some use energy use limits. They affect different building sizes, thresholds. Some are like 50,000 square feet and larger, others are different sizes. Some exclude residential, some don't. So you have to look at each one. But generally, the fines for these locations start 2025 to 2026. But building owners, or at least smart building owners, are already starting to plan, because rather than paying a fine to the mayor, they'd rather use that money and invest in improving their building. So in New York City, we've talked to building owners that have taken their forecasted fine, multiplied it by 5, and said, all right, I'm going to use that money to upgrade my building. And then that's, in their mind, an automatic 5-year payback in improving their building, and hopefully also get better lease rates, or even just to reduce the energy use budget, without having to just pay a fine that's going to the mayor, as in their words. So it's a large incentive for upgrading existing buildings, and not just the lighting and the mechanical systems, but including envelope and windows. Next slide, please. And this shows a map. This is from the IMT, Institute for Market Transformation. They have a nice website tracking all these building performance standards. And there's a national BPS coalition that's been formed. And every location you see on this map has joined that and committed to passing a building performance policy by Earth Day 2024. So again, if you are in any of these locations, it's a key opportunity for the use of low E storm windows and panels to cost effectively upgrade existing buildings to the benefit of both the occupants and the building owners. And I believe, oh, one more slide. So last, you might ask, where can I get product information, or where's product information available? 2 areas, really. One is we've worked with EPA to develop a new Energy Star program specifically for exterior and interior storm windows, low E storm windows. There's a website there, or you can just Google it. There you can find product information from participating manufacturers that provide low E storm windows. And then there's also the Attachment Energy Rating Council. Both Katie Court from PNNL and myself sit on the board of that organization. They're working on all window attachments, including things like cellular shades and automation of attachments that can improve window energy performance. But there's specifically also a certification program for storm windows and commercial secondary windows. So you can go to that website and pull up participating manufacturers, look at information on the performance of those products in both hot and warm climates. Cold and warm climates, and find out further product information. And with that, I think I will hand it back for questions.
Thank you so much to all of our speakers. So yeah, I am going to jump back on as moderator for the Q&A session. So if you have any questions for the speakers, if you could put them in the chat, which it looks like some of you are already doing, so that's great. And in particular, if you have any questions, could you try to address them to a particular person? I'll try to figure out who you're asking about, but sometimes it gets a little vague. I am looking at our questions now. So slide 10, which was probably one of mine, 20% over code, ASHRAE 90.1 2016 is shown. Why not 2019 version of 90.1? That is a great question. I don't know off the top of my head, but if I had to take a stab at it without one of my engineers on the line, I think typically just rollout of some of that code adoption is slow enough that we didn't want to be artificially penalizing buildings. But if you wanted to send me an email after the fact, I could find out the definite answer to that question and let you know. I also see the next question is for me. So how many of the 16 buildings, this may have been during my section, how many of the 16 buildings participating in the envelope campaign are new versus existing? So I think we did get to those slides. So there were fewer retrofit. I think there were about 4 retrofit in our first year, and then about 10 new construction. But we have a lot more participants than that signed up, and I do think it's a more even split. It says, are any resources of recommendations for retrofits provided to existing building participants? So yes, our full resource library is available to all of our participants. And is there any typical, are there any typical, I'm not sure what MF stands for in this. I'm not sure if multifamily, sorry. Yeah, the whole purpose that we're all here today. I was like, envelope technologies. Are there any typical multifamily envelope deficiencies found in these buildings? Maybe someone on the call who's more familiar with multifamily, maybe Tom or Piljay could speak to that. Can you guys think of any kind of typical envelope deficiencies found in multifamily buildings?
Well, I know like I was talking about, the windows are often a lacking place depending on the age of the building, but I'm curious, I'm obviously more focused on that area. So I'm curious what, what others see.
Sure. Piljay, do you have anything to add other than windows? Any typical multifamily envelope deficiencies?
So envelope deficiencies,
Well, your audio is very quiet, at least for me, Piljay. I'm not sure if, yeah, there you go.
Yeah, I put my mic on the top. So the typical, the things we can find, of course, the wall insulation and roof insulation, those kind of things, but more about that the insulation part, rather than the insulation part, we found that there's a lot of some air leakage between the units and then outside of the unit. So there is a lot of some potential by sealing the gap and then holes on the building between the unit. We can save a lot of energy from make the building more airtight.
Okay, thank you very much. And then we had, I think these are some SWIP questions, some Windows questions. So there were two here, which is how is condensate resolved with interior and exterior storm windows? And then just more generally, what are advantages and disadvantages of an interior versus exterior application?
Yeah, I think they're talking about the potential for forming condensation between the storm window and the existing window. And the general rule is whatever's more to the outside, you want to be leakier than the inside, or conversely, whatever's on the inside, you want to be tight. So if you are putting an exterior low-E storm window on, you want to make sure the weep holes are on that are clear. That's why they're there, is to help avoid any sort of condensation. And you also want to do what you can on the existing window to seal it up as best you can, not make it inoperable, but look for obvious gaps or anything like that you can seal it. Conversely, if you're doing an interior panel, you want that to be as airtight as possible. That stops the warm conditioned air from going through and hitting the colder outer surface. So interior low-E panels are designed with no weep holes, and they're designed to be very airtight with tight seals around the perimeter, and that helps avoid that question. So already that sort of answers the other question, advantages, disadvantages of interior versus exterior. Interior is generally more airtight, so that will give you a benefit of a better benefit in terms of reducing the window and overall home or apartment air leakage by using an interior. The other advantage of interior is it's obviously easier to do if you're in a tall building. If you're on a 10-story apartment building, much easier to do from an interior than it is from the exterior. Conversely, exterior, sometimes it's a little easier, depends on the case. Interior depends what kind of mounting surface you have this cell. So sometimes it can be, if you don't have much room on the interior, it might be hard to install an interior. In that case, an exterior may be preferable. Historic people, and I think we'll be talking about this next month as well, historic application, there's also a lot of strong feelings about interior versus exterior, because exterior can help protect the existing window, but then you have to be careful about the appearance and maintaining the appearance. Interior doesn't do anything to protect the existing window from the elements, but it also doesn't impact the view. So there's lots of, they're both good. There's just a lot of kind of choices that you need to consider for this specific application.
Okay, thank you very much. I'm not sure if any additional questions have come in. Tom, I see that you chatted and said that you would address a question that came in at the end of your presentation. Was there anything else you wanted to circle back and say about the low-income families questions, the disproportionate impact by utilities?
Right. I mean, well, I guess two things. One, I mentioned the building performance standards. That is a way that is encouraging building owners to upgrade their existing buildings, hopefully to the benefit of their tenants and the renters. Now, whether that results in them increasing rent or not, we don't know. That's a market decision. We'll see how that plays out in real life. But low-E storm windows in general are a very appropriate solution for low-income families and weatherization programs, because sometimes window replacement, even though I work with those people as well, and we encourage putting in as good of a window as you can, it can be expensive. So if you're looking for a more cost-effective solution, then low-E storm windows and panels is particularly a good solution for low-income scenarios.
Okay, thank you very much for that. I believe now we have answered, it looks like one more question has come in. And it is a bit of a long one in terms of text, but I will try to read it out, and this will be our last question, and then I have a couple of wrap-up slides. So we have an attendee that says they work as the utility manager for a large low-income multifamily management company, and they find that profit motive is imperative to survival. In discussions with managers of construction and resyndication, it is sometimes expedient to install conventional efficiency fenestration and HVAC equipment. How can the governing bodies balance the carrot and stick approach to making higher efficiency decisions a no-brainer to the bean counters that control loans and contractors? Efficient equipment specs vary widely by climate, utility rates, and spark spread or fuel switching rules also have significant impact on decisions. So what can a carbon-constrained world do to address these conflicting forces? So yeah, if you could just answer that whole question, Tom, in the next 2 minutes, that would be great.
Yeah, there's a lot there.
Yeah.
And it is that right balance. How do you find that balance of, equity and fairness for addressing all income brackets, but also, yes, there are profit motivations to building owners. So it's, how do you find that right balance? And so, I mean, I know from the SWIP viewpoint, and I don't know if Allegra wants to chime in, but that is one focus of SWIP, is that this is kind of hopefully finds that balance of improving energy efficiency, but in a cost-effective manner. But I don't know if PJ from on the mechanical equipment side or some of the other, you look more at the broad picture. Do you have any comments on that, on what the right balance is considering cost effectiveness between mechanical and envelope and lighting and everything else?
My kind of experience. So everything we should start from the envelope side. Of course, it's easier for the people to switch the HVAC system and heat pump, water heater, that kind of things. And but this retrofit approach, whole building approach, I think the building envelope side should be addressed first to reduce the building load as much as possible. Then we can provide energy efficient HVAC. And as I mentioned during the presentation, the reduce the building load because of the high performance windows and wall and all those kind of things can reduce the size of the HVAC system, which is a significant cost reduction. So I think this approach for the retrofit should be started from the envelope, and then we can go for the next for the HVAC system and efficiency.
Yeah, we have seen a couple of cases where someone went in and put in, very good, advanced, high efficiency equipment, and then they left the building with single pane windows.
Yes, yeah, that's exactly.
Like, no, that's not the right approach.
Yeah, exactly, that's the problem.
Yeah.
And there's just not about this question, but there's some discussion in these days going on because of this decarbonization and electrification. Many old apartments doesn't have the enough power panel to provide additional heat pump. They have a very old the oil furnace and the fossil fuel heating system, and that we are trying to replace the systems with the heat pump systems, and that will add a lot of some the burden for the existing power panel. So how we can address that issue is also one of the big issue in the multifamily sector. I just want to mention that.
All right, well, thank you guys so much for tackling that big question right at the end. And yeah, now I just have a couple of summary slides to wrap up. I will say that the final slide is contact information for all of the panelists. If you have any follow-up questions that you didn't get a chance to drop into the chat, you can follow up with us after the fact. But this webinar is not the last time that you'll be hearing from us. We hope that you can either join us or tell your colleagues about our third and final webinar in this series, titled How Historic Buildings Can Benefit from DOE Technology Campaigns, and that will be next month on April 6th, same time, same place, but historic buildings. Next slide. And if you can't wait until then to hear from us, check out the 21-22 Better Buildings webinar series. We have a great lineup of presentations through April, and please visit the Better Building Solutions Center to learn more and register. Next slide. Yeah. We also have the Better Buildings, Better Plants Summit coming up. It will take place May 17th through 19th. This event will feature engaging and interactive sessions, as well as opportunities for attendees to network with their fellow industry peers and experts. And we are planning on an in-person event this year. Registration is coming soon. Please visit the Better Building Solutions Center to learn more about this as well. And then to close out, I would like to thank all of our panelists very much for taking the time to be with us today. Please feel free to contact the presenters directly with any additional questions, or if we couldn't get to your question during Q&A, and hopefully see some of you or your colleagues here next month. So thanks everyone. Happy Wednesday.